Hello, everybody. Welcome to the stream. Today we are going to be solving some LeetCode problems, easy problems, because we need some practice on some easy problems before we move on to hard problems. So I was kind of trying to look at the middle of the linked list. You can follow the problems that I'm doing by going to this particular page. And here you go. All right. So that's the link. Hey, I'm here. And let me just pop this chat out. I put it over here. All right, I'm cool. Cool. Let's just see the quality. All right, I think we're cool. All right, okay. So I just kind of finished my work, and we're gonna be starting leak coding. All right, okay. So where's my leak code? There you go. Let's give ourselves. It's so sad that I can't edit it like from here. All right. Let's set this to 25 minutes. Yeah, I think 25 minutes per problem is okay. But we'll see. If we want more time, we'll try to use more time. Okay. Let's not start this right now. Okay, so we will be like, I don't know. Actually, can you see? Can you guys see the screen? Let me go. Here. Honestly, I don't know my OBS. Yeah, you guys can see this screen. Maybe a little bit bigger. Alright, I think that's pretty dope. Yeah, I think that's fine. Alright. Okay. And I'll be swapping around, like, I'll be doing drawings. So maybe we can turn this into some black image. And then we will be drawing. Does a pen work today? Nope. Okay. It actually doesn't work. Maybe it's a CPU, to be honest. Alright, I think we're good. We can do that and do that. Alright, okay. So I've kind of found a solution to this. It's a fast and slow pointer problem. I know this because I looked at the solution. Well, I kind of implemented an naive solution, which takes time and space. It's not efficient, but okay, let's just try to solve this problem over here. The problem is, so the idea of this problem, it's a leetcode 876. The way we solve it is like, imagine you have a linked list, right? And imagine this line over here is a linked list, and perhaps like the end of the node is none, and then so our goal is to kind of find the median, right? This point. So the way we well, the trick seems to be, the pattern seems to be that like um, we use time. We utilize the fact that we utilize time taken, the speed of 2 pointers. So imagine like you have 1 pointer over here, right? 1 pointer over here. You start off with 1 pointer here. Well, you start 2 pointers of like from location, this starting location, right? Imagine these are just just two racers, right? And one racer, like the one of the pointers, is like times two fast, times two, travels at a times two speed. Then the second pointer, which basically means like when you reach to the end, when the fast pointer reaches to the end, uh, the slow pointer would always be in the middle. Do you know what I'm saying? So what I'm trying to say is like if this guy has traveled n distance, right? Then this guy must have traveled n over 2 distance. Do you know what I'm saying? So yeah, n over 2 meaning the middle of the list, linked list, the median. That way we can kind of derive a solution. That's the main idea. And obviously you can have the nitty-gritty edge cases. We kind of need to think about some edge cases, but that seems to be the main idea. Yeah, you have these 2 pointers, and basically you're utilizing the speed, the property. You're kind of looking at the property, the speed property of these 2 pointers. Um, just to kind of digress a little bit, the last problem we solved, I think it was like detecting cycles in a linked list, right? That utilizes the space location property of these 2 pointers. Do these pointers meet at a certain location after some time? At any given time, do they meet at a certain location? Um, or like at any given time, are these two in the same location? Like, do they intersect? Yeah. So imagine these are just particles. Actually, I don't know why, but it's kind of weird. I look at things a bit physicsy, in a physicsy approach. But anyway, that's the point. That's the idea. So, how do we do this? Well, first we want to turn off the Copilot because Copilot would just literally blop out the answer. I don't know how to write tests for these. I think I do, but like I don't want to. Oh my god. Oh, do you see this? I really don't think that's a solution, but okay. Don't show me the solution. It was activated. Oh, it's deactivated. Hey, Chucky, what's up, dude? Good to see you again, dude. Long stream today. Actually, I do have to kind of. Well, you can. I don't know if you can see the time, but the time today is like currently is like 6:27. So we will probably be ending the stream like, I don't know, 2 hours maybe, max. It's definitely not 12 hours, dude. I just literally had like 9 hours of work. So yeah. So yeah, dude. I mean, I definitely need someone who can timestamp my videos with the problems. Let me know if you can volunteer to do that. I might do it myself actually. It doesn't take too much time, does it? I'll try. Actually, okay, let's focus on this problem, man. So when the fast reaches the end, let's have a look at some edge. Let's just go through some examples. So let's go through this particular example. Okay. And I'm assuming 6 kind of points towards null. I did it in Durham University. Okay, so you start from here. Where's the middle in this case? Assuming the middle is over here, like this. The middle is here. That's what the question says. Okay, let's run through this. So when this is here, here and then here, this is your pointer 2, right? And then this is your pointer 1. Okay. Sorry, pointer 1 would be in this location, and then pointer, the slow pointer would be in this location because it's like 2 times faster. And then your pointer 1 would be in this location, and then your pointer 2 would be in this location, right? Yeah. And then this location, and then pointer 2 would be pointer 2 would be over here. Sorry, the slow pointer would be over here. So I'm kind of doing time 1, like I'm kind of visualizing this as like this. By the way, so this is time 1, and this is times 2. So 3. I'm not actually stressed, dude. I'm actually quite chill. Maybe this is just me. I'm just trying to think. And then pointer, dude, I lost my train of thought. Holy, 1, time stepped here, and then time step like 3. Be here, and then this guy would jump over here. So right, okay, so I'm assuming if it is even, then the fast pointer will be, it's when it's when the fast pointer is at the null location that we wanna. What about odd? Does that look? Okay. Alright, let's do some time series over here. At point 1, the pointer would both be over here. Right, and obviously we want this, look, this is the median. And time 2, what will happen is like this guy would jump over here, and then this guy would jump over here, right? At time 3, what would happen is like this guy would. Oh, that is weird. Oh yeah, this guy would be over here. Huh. I mean, the edge case. Uh, the edge case for this would be what, like just one, and then both pointers would be over here. All right. Okay. Let's handle the edge case. Well, I mean, doesn't the algorithm automatically handle edge cases? Like, be honest, I don't think so. While fast.next is not none. What you want to do? Well, what you want to do is like, you got your slow. I know what you want to do is like. Oops, sorry guys. I need to kind of show you guys the code. Our slow would be what? Yeah, the fast moves twice, the slow moves once. Is that it? Like, all we have to do is like return. I mean, technically, right? What we just said over here, right, is like in this particular image, what we just said is like if the fast reaches none, then the slow is automatically in the correct position. Um, right? In this case, in this scenario, the slow cannot reach none, right? Because so time step 1, time step 2, time step 3, right? At time step 4, this guy tries time step 4. This guy time step 4. This guy tries to jump off over here, right? Like, which is not possible. So we'll have to handle that as well. Okay, well, let's see. What is it even? I mean, even like when it's even, shit can like. We can't be. Uh, what happens even in the even case? Like, uh, sorry, this is the even case. Oh. This is the case. Like, this is when like we have number of nodes. Number of nodes is even, right? Um, and this is like number of nodes equals to like odd, right? This is the case, odd case. So it's in the odd case like that we have to be careful. Well, I'm assuming in this case, like if the next guy will be, yeah, I get it. Okay, cool. That's the case. Then what do we return to? Yo, I'm so sleepy, dog. Like, not even gonna lie, I hadn't had a good enough sleep today. Uh, then just return slow. Okay, guys. All right, let's see. Let's see if this works. I think it worked. Oh no. Yeah, that is true. What if it is none? This is the case of even, right? Yeah, this definitely can be none. Can we just go like return slow? Ah, there you go. There you go. I had this was my I tried a lot of times. Um, I was kind of testing out test cases really, to be honest. But okay, this was my not like uh like brute force solution. This is a bit like optimal off end solution. Which is okay. Hi, yo. All right. All right. Shall we go on to move on to another question? Okay, let's take this one off. Um, Chucky, are you still there? Bro, what's up? You still there? Uh, bro, let me know if you're still here, bro. Like, let me know how I can improve this stream. Um, that'd be super helpful. You know, like what is it that I could do better with the streams? Um is it talk more, talk less? Like just anything. Like what do you think can be improved on the stream? Um, and I'll try to make it happen if it is feasible. All right, we're gonna try reversing a linked list. Oh my god. Oh my god, guys. All right, isn't this like a popular question? I see this on YouTube a lot. All right. Looks like Chucky is gone. All right, this is. I'm gonna create a new file. I call it 206.py. And then what we're gonna do is like copy and just paste some things here. All right, so what we gonna do? I think the question is kind of self-explanatory. I have to implement both. Okay. Okay, let's make it happen. Let's make it happen. So I don't know. I actually don't know how to reverse a linked list. God damn. Like honestly, like I've like the amount of time I use linked list is like none. Like I should be using more, but maybe I will use if I once I kind of get a developer. You know what I'm saying? All right, so how are we gonna reverse a linked list? Yeah, how are we going to reverse a linked list? Question of a century. Okay, let's have a look. Well, okay, let's go to the edge case. If this is reversed, then I'm assuming the output is just 1. Okay, I can't think of any other edge cases. Like 1, maybe 2. But then, okay, reversed is after you apply like the reverse function, you get like 2 and then 1. Okay, how are we gonna do this though? Let's not look. So let's say like you got. Let's say this is a linked list, all right? This line over here is a linked list, looked viewed from a very far distance. How are we gonna do this? Well, we can put a mirror here. I'm joking. That would be quite creative though. Like put a mirror here, and then this would kind of. Anyway. I mean, what's a logical thing to do, like for the most simple case, like this and 1 and 2, like how would you do this? Like, if someone literally told you, please reverse me this 2 like thing, how would you actually go on about doing this? All right, okay, let's look at it from a far point of view. Like you got 2 nodes here. How would you do this? Okay, well, we need some kind of like bucket or something, right? To kind of store this somewhere, right? Meaning, obviously, like our first step. Okay, let's look at this time series over here. Let's look at a time series over here. Uh, a t equals to 1, right? Uh, t. A t equals to 1. This is, by the way, arrow, and then this is arrow. Like, um, okay. Hmm. A t equals to 1. What do we do? I mean, assuming like, okay, this is like 1, and this is 2. Okay. Um. So, well, I'm assuming you have to point this over here, right? Um. Well, this would be still be pointing over here. There's null. We make it point to this guy. And then what we do is then after that, so we have this guy pointing over here, and then what we do is like we start pointing over here. Then we have like our head to be like points here, here, and then this we have our head like this. I think. Not quite sure. All right, let's try one example. Like, let's try with 1 and 2. All right. How are we gonna do this? T equals to 1. Uh, okay, this is by the way null. Mm. I mean, we could definitely like have this going on here like that. At t equals to 1, we have access to this particular node, right? We have access to this particular node and nothing else, right? So we have to kind of start at the start somehow. I mean, the head must point towards null, right? So we know that, right? The first head must point towards null. It could be any null, but well. Okay, maybe I can kind of explain this a little bit properly. So we know this is pointing this. So what we do is like, well, we create a new node over here, and we make two. Can we make like a dummy node point towards here, like a dummy node, and then this point towards null? And then like make to point here, something like that. Actually, we might not even need the dummy node, you know. So we might just go like, okay, first head, I know it will be the last one, so, and then the second one will just be like, okay, the actually that might not be the first thing. So we know this is pointing towards this, so we might use like once next dot next and kind of point it towards this, but then we would be losing what's, you know, what two had been attached to. So what we can do is, like, say there were more nodes, we can make a dummy node and perhaps like point towards this, like, you know, after like this particular point. So I'm currently now I'm kind of like playing around with this scenario, like where you have like a lot of like, and then you got the end, right? Oh god, wait, hold on. This is a little bit confusing because I started with two. Uh, but I feel like talking about it generally should help. Okay, let's consider the general case. All right, let's consider the general case, which is like a 1, 2, right, and then you have like some, and then like may say like, I don't know, like 5, and 5 points to null. Okay, 5 points to null. Okay, how are we gonna reverse this? Let's look at the time series for this. Well, we have access to one only, we know that. The currently head is pointing towards here. So let's just put a head star over here, right? Head is our star. Right? So I know this has to point towards over here. And then like 2, you know, you got the 2 and then the rest of the world, right? Now I need to make, like, if I just point 1 to the null, I'll lose everything that the 1 was pointing to. So what I need to do is kind of somehow like be able to store, like, you know, somehow remember like what this was. I mean, I guess if I before pointing towards null, if I just kinda like save this, I don't know, like, okay, so save this with this particular variable, then what happens? Then, oh shit, okay, we can do this a bit recursively, innit? Say 3, right? Yeah, we can kind of do this recursively. Like, I can kind of feel recursion here. Like, I can just kind of feel it. Like, I can just kind of feel it. Um, I can just kind of feel the sense of recursion happening here because I feel like I'm just doing the same task over and over again. Um, so point 1 towards this, and then point 2 towards whatever it came before, and point 3 towards whatever it came before, and point, you know, yada yada yada, like keep pointing towards, and then say the last is like 5, you know, it points towards null, right? We make it point towards the next bit before, and obviously we can kind of check this is the last node because if it is, you know, pointing towards null or not. And if it is pointing towards not, we may pretty much reassign this as a head. Yeah. So the way it's gonna work, like I really need to, like, okay, as I'm doing this, I'm developing a framework to visualize stuff like a time series analysis on the array as I'm going through this. So the time, like, viewing this as a graph, like I'm trying to view this as a graph, where where the upper row is t. Um, I don't know if it is helpful or not, but like, let's see. If it is not, I'll just kind of bend it in, like, after a few questions. Um, but I can already see like some complication of this method, of like me, it's being like not being able to capture what's happening, and it's being slow, like, to capture. Anyway, so one. So for any number, right, x, like, in the middle, like, you can have that, right? So all we need to do is make this guy point towards, like, the parent. Like, make this guy point towards that, its parent. And how would we know this particular thing? Well, we can kind of store it into, like, say, p equals to whatever this thing is. So when we're fixing this, and then yeah, so parent now, therefore now after doing that, parent, the head would be over here, like, and assign it as the head. And then in the next step, when it's y turn, well, we don't need to think about y turn, right? Like, we can just kind of like recursively do this. I hope I explained this question a bit correctly. But let's try to implement this. I don't want to talk too much. But I think we kind of have a sense of a general idea, like, where we want to take this. Turn if it is not, what we want to do is, like, we want to hey, dude. Hey, FN. I don't even know, dude. That's probably not your real name, baby. But hey, what's up? We doing leetcode 206. The link is on the chat. I think. All right, so head next is none. What do we want to do next? All right, so if that's not the case, if this is not the case, then obviously it would be it would have something. So what we want to do is, like, well, I know this head dot next is gonna actually, the head dot next is going to, okay, I'm just gonna write pseudocode here. Point towards points to parent. Okay. Uh, but then if we do this, then we kind of lose head next, right? Like we kind of lose what head next was referring to. So what do we do? So, child. Let's say child is like, I don't know, head dot next, right? So we have to save this in here. And parent. Okay. Actually, it's not. Like that. Okay, I'm just kind of like pseudo coding this. And let's see. Okay, so we got parent and child. Um, what's the next sensible thing to do? Well, we have to send the child points toward parents. So yeah, parent. This kind of points towards parent. What about the child? We have not done anything with child. What's the most sensible thing to do with the child? Yeah. All right, let's solve this recursively. So we might have to. I would wanna. I wanna name this variable. But the only thing over here is, dude, like, parent is not always none. So, like, you know what I'm saying? This guy is not always true, depending on what node we're iterating on. You know? So the idea is like we want to call like self dot reverse list, and then some. I think like that, right? The idea is to kind of do that, and then some this is some magical function that kind of like reverses the list entire thing of the child, right? Um, like that's how I kind of think of recursion. It's like, okay, this is a magical function that kind of like reverses the child list, and what we want to really do is just like, okay, so okay, child reversed. All right. So what I'm getting over here is this, like, so what I'm getting over here is that like, there's some magical function. So imagine like, um, one pointing towards two, and then dot 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 dot, right? And then you got null over here, right? Okay, so something like that, right? So this is there's some magical function that the magical function what it returns is like five, and then like the end dot 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 two. Okay, that's the thing it will return us. Now how do we attack? What do we do this with one? Well, with this one, what we can do is use two pointers. Oh, god damn it! It was a two pointers problem. Okay. Yeah, the magical function could use two pointers. Yeah, it. Let's see how I can use two pointers. Um, I'm. Well, okay. In hypothetical, like, okay, if we had like just talking about a solution, right? What we want to happen. What do we want it to happen? Like, what we want to happen. Like, what do we want it to happen? All right, with this one. Well, we want this one. Like, we want this two to kind of be pointing towards one, right? Okay. Well, how do we do that? Well, we need to have access to this two, right? Okay, well, how do we have the access to this too? Well, we need to kind of somehow like keep a reference to this too, right? Um, and where does this reference come from? Um, that's a good, that's a hella good point. Oh shit. Okay, cool. The magical function will return us. Well, okay. Well, we want like a final output of this, right? We want this to be returning like the five node, right? So we can kind of return everything that's attached to, we want to be returning like this five, right? The end of the thing, right? So how do we know what this is? Where this is? Well, we need a pointer. We need a reference to this, right? So I'm assuming we have to kind of keep a reference over here and reference to this particular point. Okay, well, how do we do that? How do we even begin to have reference pointers? Well, let's have a look. Okay, well, we start with one. Uh, okay, well, one is the head currently, so we want this to be the head at the very end, and we want this to be the tail at the very end, right? Um, okay, well, at the very beginning, what is the head and the tail? Like, like naturally the head would be this, and then naturally the tail would be this. Okay. Okay. Um. Right. Okay. Cool. Yeah. Go on. I think I'm on the right track. I think. Um. But if not, I'm sure that my logic will break down somewhere. So, but keep on going with this. Um. Okay. Um. Okay. Also, what is the simplest thing we can do at a top level, and then we can just kind of pass it down? All right. What's the simplest thing we can do? Let's see. Uh, okay, and then we have dot dot dot, right, and then goes to somewhere infinity. All right, or five. Okay, like okay, for each pair of nodes, you have to reverse the link pointer A to B. Yeah, that's exactly what I thought. I mean, so for right, okay, so for this particular node, we reverse it, and then for this particular node, we reverse. So our simplest task would be to just reverse the node. For every node, we just reverse it. We just look back. We just make it look back, and then keep asking it to look back. Okay, well, let's see. Sometimes you writing the code kind of like helps me to kind of like things connect when I write the code. Let's try to write the code. All right, so for head, right? Well, we need to reverse. We need to let's do the simplest task, which is to reverse this particular head dot next. I know what this to like some. Okay, list node val. Okay, val equals to none and next equals to none. I know there's some problems by doing this. One thing is like we lose reference to next, like what the head next was. So I'm assuming what we do is like recurse on, okay, head dot next. So we need to recurse on that, and then what? But this is not always true. We don't want always. We don't want head next to be. Use two pointers. The first pointer will point towards A, and the next pointer will point towards B. Okay. All right. Let's try to use that pointer analogy. All right. Pointer. P1 equals to like say head. All right. And P2 equals to like head dot next. All right. What can we do with this? All right. Well, P1 next. Yeah, but if we like the thing is like I really want to do this, right? Like just like P1 dot. I really want to do this, but and fuck, it's so stressful. I really want to do this, but then what happens? The problem with this, right, is that like Ah, right. Okay, hold on. Okay, I think we need to like have a. Uh, use two pointers. First pointer will point to A, and the next point to B. Um, yeah, that's exactly what I do over here, and then pointer one. Yeah, I kind of need to visualize this a bit more. All right. So one, two. So this points. This is P1, and this is like P2, and I was like, okay. Now what? Now this guy would. Now this guy just points towards none, right? Or would it? The only thing is like it, like in the code, right? Like, uh, yo, let me think about this. Let me just shut up and think about it. Cause the more I talk, the more I don't know why. The more I talk, the more I just jumble up my logic, and it's like, uh, let me just think about this with just shutting my mouth up and just thinking about it. Um, All right, yo, give me a sec. Give me a breather. Let me think this without actually going in there. Ah, yeah, that's not right. So whenever we return something, yeah, that's not right. Oh, actually, maybe that is right. All right, okay. But this function needs to return till. Okay. For now, we don't know what those are. Sheesh. Is this it? Oh, like what kind of thing? Oh, okay. This is. Okay, guys, I think I attempted something. Uh, let's try it. I think it failed. Ah, what's wrong? Hmm. Oh, right. I think it will fail. Okay, looks like the problem is not getting smaller. Ah, yeah, the problem is not getting smaller because we have not. Okay, let's bring back our code. Self. The problem is not getting smaller. Hmm. Yeah, let's try this. All right, let's try this. I have a feeling that it won't work, but I have a feeling that it's just P2. But all right, I have a feeling that's that. The problem size is not getting smaller, guys. Hey, dude, still working on the problem, man. Uh, the problem size is not getting smaller. P1 is P2. It's I literally don't have a visualization tool because I'm so new to this like linked list and whatnot. I literally like don't I'm not able to visualize this. I'm literally just kind of like, thinking like two steps ahead. I don't have no image in my head. I mean, so it's like quite difficult in that sense. Is our base case okay though? Oh, next. I don't know. Okay, what the fuck am I doing here? Like, literally. P2 next. P1. Oh shit, I was eating my shirt. I'm hungry. I mean, that's what we had in the beginning, though, right? This is kind of weird. Bro, what's wrong with chewing pen and you? Don't want to chew pen. I want to chew the problem, bro. Alright, okay, well. Literally, it's here, bro. Oh, we did it! Bro, it worked! There you go. I let too long. It took a while. It took a while. It took a while. Oh, it worked. Bro. Oh, that feels good. That feels good. Damn, it worked. Oh, damn. Bro, that took so much mental effort. Oh. Like, I was just like pointing in my head, all the pointers were going like, yeah, oh, god damn. Like, to be honest, like, if you ask me how I did it, I would like like there wasn't like, okay, I managed to do it, right? But there what I didn't do it through a like a systematic process. It was just kind of like one step at a time, you know? Like, yeah, I think what really helped me was this particular visualization. Um and what I really noticed is like, why am I like what really helped me was like setting this dummy start node. um I think the intuition I can take away from it is like, when I was recursing through the I was trying to recurse, right? I was treating one like it was a very basically, right? This magical function we have, this magical function I wrote, like the recursive function I wrote, recurse, I think it's recursed list, something like that, right? It takes in like p.1 and 0.2, right? Okay, basically the recursive function needs to be applicable for any points in the list. And I've done like recursive problems like when I was in a but one general theme seems to be that like the recursive function that you're writing, right? Uh is it needs to be it needs to be like it needs to handle any point in this list. So I cannot, because it's the first, like, because it's the first one in the item, like in the linked list, I cannot treat it differently than any other. So the only way to kind of treat this, like, in the same way that you treat other is like, well, just have a you know, dummy node. So the dummy node can go over here and one can go over here, and then you can kind of start doing your simplest task. Yeah, literally, I think that was the main problem. I literally couldn't define the simplest task, like the atomic task for the first one, because I mean that was the problem, right? Because I literally did not know, because it was such a special case for this one, because the one had to kind of point towards null, right? Um, One had to kind of point towards null, and it was kind of different from if like your 2-3 or the middle of the list, right? So yeah, it was. I just couldn't define an atomic task for this until I realized that, oh wait, I can just kind of create a node, like a dummy node, and kind of treat it like, kind of pass this into the function. Um, and yeah, and that seems to work. But now we have to do it iteratively. How do we do iteratively? I don't know. Do you like momos? Dumplings? Yeah, I do. I don't eat a lot though. It's like I had it recently. I had like 10. 10 depending. Like my fitness pal says like 10 dumplings is like 90 carbs, which is okay, but just makes me feel shit because I think the carb to protein ratio is not too good. Like, or just the content of the food. I don't know. Yeah, it just makes me feel shit and lethargic. You know what I'm saying? So I don't actually. I'm not. Yeah, I wouldn't go my way to kind of like find them and eat them unless I've not eaten them in a while, like while. So yeah. What about you? Do you enjoy having dumplings? My mom cooks them a lot. Um, but yeah, what did I learn from this? I don't know. This dummy variable. That's what I learned. I don't know. It was just doing a problem. All right. Okay. Can we do this recursively though? Sorry. Iteratively though. Bro, this literally. Uh. Can we do this? Can we do this Can we do this iteratively though? How are we gonna do this iteratively? Usually iterative is kinda, I would say, simpler than. Damn, dude, there's another problem called reverse linked list 2. No shit. Problem. Balls are sweating on first. Easy problem. There's like 2. Oh god. I don't even want to look at these like more child. Like let's take it a step by step. All right. Let's do this iteratively. I mean, it's a kind of a fun problem. Not gonna lie. Okay, cool. Yes. Actually, I just kind of feel like a bad. I think yes, I do. Uh, Oops. All right, how are we gonna do this iteratively? I think having a dummy node actually helps a lot. I think now that I got like what I need to do, I think it's not none. Isn't this it? Like, isn't this just the solution? Hmm. God damn. Ah. God damn, dude. Alright, okay, let's think this through. Man, this shit is, man, this question is like hard for me, yo. Why is there like why am I reassigning P1 again? Like it's so dumb. Like why am I assigning like P1 twice? That is so dumb. Though I don't know which one. Yeah, I don't know why I was reassigning P1 twice. Okay, well, that doesn't work. What the hell is going on, dog? Like, literally. Yo, for some reason, writing recursive solution was easier than writing the iterative one. All right, what am I making false assumption of? Okay, all right, let's start this. Clear from cache. Let me remove my cache in my head. All right, okay, well, if head has no next, then return head, right? If it has next, then what we can do is like we can iterate over the basically reassign everything one by one. So while head All right, let's repoint the tail. Let's make the tail point towards head. Okay, that's... But then we don't want to lose the thing, so we do this. Okay. And I think that's it, really. I mean... And now the head becomes the tail. The head becomes what the tail was. And the tail becomes what the... well, tail becomes temp. I think that's literally exact same code I wrote. But... And after that... What you want to be returning is maybe not the tail. Tail is not none. Well, I'm assuming the tail becomes none at some point, right? Because it reaches a thing. So we want to do like next. We don't want it to be none. So maybe we can return the tail like this. Okay, so we're returning 5, but looks like this has this. Why is the tail not pointing towards anything? Why is this not pointing towards anything? Well, because we have not pointed it towards anything. Okay, well, why haven't we pointed towards anything? That's a good question. Why haven't we pointed towards anything? I thought I did. Well, it definitely hasn't, so... Okay, well, what is the wrong assumption that I'm making over here? Well, any assumption that I'm making is like one of the assumption that I'm making about the pointing is wrong. Okay, must be wrong. Well, okay, where is this assumption coming from? Let's check like through. Okay, let's write my thought. I don't know. So at the end, right? At the end, t equals to 5, but obviously it must be 5 because that's what it returns 5. But it's not pointing towards anything. Well, okay, well, what does it need to point towards? T needs to point towards like a group of number. Okay, well, we do kind of say T to point towards thing, but then we reassign T over here. Okay, so imagine I guess like when temp equals to, okay, I guess temp is 5, and then T over here, and then 5 next is not none. Well, the second last node, which is the very last node, doesn't get to run this thing. That's why it's not pointing towards. Okay, well, why doesn't it get to run this? Because, well, the dot next is not none. Because, okay, t dot next is not none. Okay. Sure. Okay, so I'm assuming now fifth node gets to run this as well. So it comes over here and it goes like, hey, look, um, dot next. It doesn't have next, which is none, and then temp. I guess, mm, I guess if it's like, I guess like if t is none, um, return return head like this. Return head like this. Okay, while t is not none. Well, this really doesn't matter, right? Well, one, we just want to iterate, and then we just want to keep doing it. Like, we just want to keep swapping this pointer while t points to the next. Well, t points towards the head, and then yeah, that's it, pretty much it. And we want to do this, and then eventually we will. Okay, well, let's try it out. Okay, let's try it out. I have a feeling that won't work, but error found cycle in list node. So I'm assuming it doesn't like this. Alright, let's try this. Alright, let's try this. Does it like it? Found cycle in the list node. Okay, well, I have. Oh shit! What did I do? What did I do? What the fucking press these? Oh, there you go. Things like the head is not pointing. You see this? It's wrong anyway because the head is like the first head needs to point towards none, but it's not doing that. Huh. So first head needs to okay, so tail, okay, cool. Well, tail is not none. Well, tail cannot be like next. Okay, so what do you want to do? Well, if it is tail, okay, well, imagine. I mean, it can't be none because, like, hey, like this case already handles it. But I guess we want to iterate through the very last node, right? Like the very. Okay, if tell is not none, then we want to do this. Okay, well. Okay. Then you want to, like. Basically, head points towards the tail. Okay, the tail points towards the head. The tail points towards the head, and then the head is like, bro. I'm just trying to do all these fucking thing in my head. It's like, and then the head is tail. Mm. All right, all right. Let's try this. I have a feeling that this might work, but who knows? Non-type object has no next. If head next is none, what the fuck are you on about? Non-type object expected output head. Okay. Oh shit, that worked. I don't even know, dude. I don't even know how I did it, bro. Oh god. I mean, sure. I mean, I sort of know how I did it. I mean, like, I kind of did it myself. Like, but it's still like super fuzzy, like how I actually got there. You know what I mean? Like, I don't have like if I have a feeling that if I do this question like in like 5 days, I'll probably struggle again. Um, yeah, that's what I feel like. But hey, at least we did it. We solved it. Right. That's the most important bit. We didn't. Well, I mean, I guess like we kind of had some help from logo Titis logo DTs. Literally, I think his name is logo Thetis. It's not titties. Uh, anyway, I don't know what these numbers mean. I mean, it looks like a distribution runtime. I heard that these are not quite accurate. It doesn't reflect your runtime. But like, bro, these I'm pretty sure it's optimal. It's like, oh man, like, um, honestly, I'm pretty sure solution is behind the pay bar. There you go, locked. Um, I think that's pretty much it, really. Tomorrow I'll be waking up early, like 4 a.m., and then trying to like do more leak code questions. Oh, it's neat code. Lol, it's this guy. Oh no, wait, hold on. He could have just embedded this. Alright, let's watch their solution. I mean, let's look at how he sees the problem. Oh my god, it's 11 minutes. I'll turn this off.
Hopefully you can't hear it too well. So today let's solve an easy question, reverse a linked list. And this question is actually like a sub-problem that's needed in a lot of other questions, like linked list related questions, so it's definitely good to understand. So just like the problem says, we have a linked list, we got some nodes, and we just want to take each of these links, reverse them, keep doing that with every link, and then this is going to be the new head, and then we're going to return that. And they tell us that this can be done two ways, iteratively, meaning with just pointers, and also recursively, and I'll show you how to do it both ways. So we can do this with 2 pointers because we want to reverse it. So like from the perspective of this node, instead of the next pointer pointing at 3, we want it to point at the previous node, 1. So if we want to do this iteratively, we can use 2 pointers like many problems. Now what are the 2 pointers going to be? We can have initially a current pointer, so we can initialize current to the first node, which is our head, and we can also maintain a previous pointer, which initially is going to be set to null. So for the first node 1, we're going to take the next pointer and reverse it. So now the next pointer is going to be pointing at null. So this is now going to be the last element in our new reversed linked list. So now we can shift our pointers. So we're going to take the previous pointer and then shift it to current, and we're going to take the current pointer and shift it to the next node. Now since we broke this link, we have to save this somewhere before we end up breaking this link, and I'm going to show you how to do that in the code. So now our current is 2. We want to take the next pointer and reverse it. So the next is now going to be like this. So it's going to point at previous. So we can reverse the next pointer and set it to previous. And once again, we're going to shift our previous pointer to current, and our current pointer is going to be shifted to next. Now we're finally at the last node. We can once again update the next pointer of this current node. And so now when we update our pointers, previous will be here and current is going to be at null. We've reached the end of our list. Now we want to return the head. How do we return the head? Lucky for us, the previous pointer is equal to the new head, right? So this is going to be our result. Just like in the drawing, we can initialize our pointers first. Previous will initially be null. Current will start at the head. And we want to keep going until we reach the end of the list. So while current is not null, we're going to reverse the pointers. So we want current.next to be set to previous, and then we can shift our pointers, right? So we can update previous, set it to cur, and cur is going to be equal to current.next. But notice how we set current.next to previous before. So when we do this, we actually are going to have a temporary variable called next, which I will do at the first line when we start our loop. So we can save that in next, so then when we update current.next, we still have that next pointer. And lastly, we return the result, which we know is stored in previous when this loop stops executing. So it works, and this is actually the most optimal solution. The time complexity is big O of n, and the memory complexity is big O of 1 because we're just using pointers, right? No data structures or anything. But if we want to do the recursive solution, then the time complexity is also going to remain linear, but the memory complexity is going to be linear as well. So we're going to need extra memory. So it's not the best solution, but I'll still show you how to do it. So usually the best way to think about recursive problems is to break it down into a subproblem, right? So if our initial head is 1, we start at 1, and this is our linked list, right? But let's say I want to do a recursive call. Instead of reversing the entire linked list, I'm going to reverse the remainder of the linked list. So everything except this 1. So now I have a subproblem, right? Now I only have 2 nodes to deal with. But let's take it one step further. This is now my new head, right? And I'm going to break it down even more. I'm going to say reverse this portion. Reverse the subproblem. Reverse only 1 node. So then, if we try to break it down even more, then we're going to get this is our sublist, right? But this is just null, so we can't really reverse that. That's the base case. So now we're at this. We only have 1 node, and we want to reverse it. How do we do that? Well, the next pointer is pointing at null. Instead of that, we can take the next pointer and set it to previous. Not really, because this is recursive. And at least the way I'm going to do it, I'm going to keep the pointer pointing at null. So we technically reverse this portion, which is just this, right? It's just a linked list of 1. So now we're going to pop back up out of our recursive call, and now our job is to reverse these 2 nodes. So since we're at 2, we can access 3. So what I'm going to do is say, okay, the next pointer of this is actually going to be set to me, is going to be set to 2, where I'm at right now, but my next pointer, 2's next pointer, is going to be set to null. So notice that so far, we have done our job. We reversed a linked list of size 2, right? This is going to be the new head, and this is the tail, this is the end of the list. So we did our job of reversing these 2 nodes, but we still have 1 more node, so we're going to pop back up out of our recursive call. Okay, so now we're finally at the last call. So our subproblem is to reverse these 3 nodes. And we can repeat the same thing we did over here. We're going to, for 1, since 1 has access to 2, we're going to set 2's next pointer over here. Instead of null, we're going to set it to 1. And the next pointer of 1 is now going to be null.
Yeah, but how are you going to get the head?
This is going to be the new end of our linked list. So we've done our job. We recursively took our linked list and reversed it. The only problem is that we are doing this recursively, so we have to, in our code, we're going to have to maintain the last node as the new head. So now let's code it up. As with most recursive functions, you want to do the base case.
Yeah, but like, how do you save the new head though?
Return null. And I'm going to make a variable to maintain the new head, which I'm going to initially set to head. Head is the current node that we're at in our recursive call. So if head.next is not null, if there's still a subproblem, if we can keep reversing, then we're going to have our recursive call. So reverse the list, pass in head.next, and the return value of this we are going to have as the new head. So if this returns something, so we're going to set the result of that to new head. And since head.next is the next node of head, we want to reverse that link. So what we can do is get the double, so head.next.next is going to be set to head. What this is doing is just reversing the link between the next node and head. And lastly, we can say head.next is going to be equal to null. So if head happens to be the first node in the list, we're setting the next pointer to null. And of course, this function wants us to reverse the list and return the new head, so we're going to return the new head. So this works, and I think it might be a little confusing the way I wrote it, because we have head.next.next, but if you want to understand it a little more, I would try to mentally run through a couple of test cases. For example, if you were just given 1 node, if you were just given a linked list of this, try to run through the code, see what the code does, see what the function returns, see which, this statement would not ever execute if we were given a linked list of size 1. This is not going to execute. So just kind of try that out, see what happens if you had a linked list of size 2.
All right, let's
like
see
this.
his
And just kind
solution
of make your
though.
draw picture.
I feel like it's similar in some sense, but like he didn't have to kind of create a new function though. I mean, I had this idea, but I just did not know how to track of the head. I'm trying to think how he like. I'm kind of confused about this particular part, like where head.next.next. Like, what does that even do?
Next. But if you want to understand it a little more, I would try to like mentally run through a couple test cases. For example, if you were just given one node, like if you were just given a linked list of this, try to run through the code, see what in the link this returns something. So we're going to set the result of that to new head. And since head.next is the next node of head, we want to reverse that link. So what we can do is get the double. So head.next.next is going to be set to head. What this is doing is just reversing the link between the next node and head. And lastly, we can say
I have no idea what he's doing over here. I mean, I kind of get the recursive call, but like,
head.next is going to equal to null. So if
is it because of line 14 that makes a big difference? Guys, I do kind of have to leave now. Like, I mean, leave soon. I'm like hungry as hell. I've been in this room for like, bro, since like 8, 8, 9 ish. But it's almost 12 hours, bro. Like, um, head.next. Oh, that's weird. Now that's weird as hell. Like I don't know why you do that. Yeah, I mean I see why you do that, but like, bro, like, ugh. Okay. I really think he's trying to do this. Uh, so imagine you have like nodes going through, right, like 1, 3, and then like dot 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 dot, right? So the recursive call kind of gives us like this part, right? Like solve this part solved for us, right? So like it'll be reverse, right? So this would be the tail, and then this would be the tail, right? Like I think so. Think. To be honest, dude, I can't. I'll have to like. Yeah, I'll kind of stop on this question for now. All right, let's log this out and then call it a day for today. I gotta wake up tomorrow and then we can kind of start. Um, you can see my consistency has not been on point. Which is something to improve on. I think that's one of the reasons I feel like I'm struggling a bit is because my consistency. Okay, link. Okay, what have we finished today? Today, linked list cycle. No, we didn't do that. Okay, I think we did the middle of the linked list, right? Didn't we? How hard was this? Yeah, we did this. Alright, I think we can kind of close some stuff out here. And what did we learn over here? Yeah, we learned that Floyd and Tort. Fast, slow, pointer, using inference in speed, making speed. Okay, 28 November 202. Yeah, this is gonna be I would say this was like a pretty hard problem as well. Like I'd say like let's give it out of 10. No. Let's give oh my god. Oh my god. Alright, let's give it a like 10 out of 10. And then the next problem we had was like reverse linked list, which was like description. Bro, like look at us, man. Like we did some complicated shit. Okay. To be honest, what did we learn from this problem? Recursion and fuck, everything is just being hard. Like, I don't like this fact, man. All right, okay. Let's push this out and then. Actually, how do we get status? Okay. Damn, this is so huge, dude. Alright, let's just push this out. I don't know. Changes. Work in progress. Alright, okay. That's that. Alright, guys. Thanks for joining today. That is the end of the stream. It was kind of boring because I was kind of just like ranting a lot, but thanks for tuning in, Chuck Key, and always, like, I really appreciate it, bro. Like, you know, it's nice to see someone in the stream, and I'm not alone. And FN Logi, these came through and kind of gave me some hints and guidance. That was well appreciated, bro. Thank you very much. I couldn't chat because I was trying to, like, really get this problem through today, but we kind of got 2 problems through, and I totally forgot that we have this thing right here. I forgot to update that, so maybe next chat, like maybe next stream tomorrow, I'll kind of update that. But for today, I think that'll be it. All right, ciao, guys. Ciao, bye.